solution rather than word root, but you need to know both of these terms so you understand where you cross the axis. Make sure you've written down any of the key facts that you need to help you revise for this in your exam. Now, the first step to be able to work out this root of this solution that you can see here that we worked out on the other page is using the change of sign method. So to find the change of sign, it is, as the name suggests, looking at positive and negative. So I'm looking for a positive answer, I'm looking for a negative answer, and that change of sign shows that the solution is going to appear here, and I'm going to show you an example of what I mean. So this is used to show that the root lies between the two x values that are given. Now, in the exam, they're going to give you two x values. So they'll say the solution is between the point 1 and the point 2. So it's normally between two whole numbers. If they don't give you these two whole numbers, you can work it out using trial and improvement, and you could just put some values in, see which ones give you a positive answer, see which numbers give you a negative answer when the numbers are 1 apart. So they don't have to be given to you, you can work it out yourself. Now your function must be continuous. So this is a continuous graph because there is no gap in the graph. So a non-continuous graph could look like a horizontal line, a gap, and then jump up here and go horizontal again. So that is what a horizontal or non-continuous graph would look like. But this graph here is continuous, so it continues between where the root is here, between my 2 points here, 1 and 2. Now you're going to substitute in your values for a and b into the function f of x equals 0. So you have to rearrange your equation to get it equal to 0 if it isn't already equal to 0. A lot of the time the equation will already be given to you as equal to 0, but sometimes it's not, so just check the question carefully. So if I say a is this point here, if I put a value here, which is probably about 1.8ish, 1.7, if you put a value in here and you work out the value by putting that 1.7 or 1.8 into this equation here, you can see the answer is going to be negative for f of x because it is below the graph, below the horizontal axis. So when I substitute a in, I'm going to get a negative value out for the function f of x. So this is a negative part. So you can see here when f of a is calculated, you're going to get a negative value. It's less than 0. So you need to say it's going to be negative. You can use the notation here, less than 0. And if you find it helpful, you can say that it is below the x-axis. But really, all you need to state is whether it's negative or positive, or you can use the inequality notation if you prefer. We're now going to look at a point B, which is the other side of the root. So it's going to be closer to the 2. So just over 2 is my point B. And if I draw a line up now, you can see when I get B, my answer is going to be positive because the graph is above the x-axis at the point B. So now f of b is going to be greater than 0, which is positive, so the graph is above the x-axis. Now in the actual exam, you can work out the value of f of a and f of b, and one of these will be -2, for example, and +5. So you've got a positive and negative. So you've got a graph which is below, the graph is above the x-axis, which means you have got a change of sign. And this is because f of b is positive and f of a is negative. So this change of sign, you must state in the exam there is a change of sign. Okay, because these two values here are different. One is positive and one is negative. So in the exam, you can then say, therefore, you've got a root or solution which will lie between x is equal to a and x is equal to b, and you can use the actual number values here. So we're going to use a number example in a second to show how we're going to do this. But remember, you need a positive and negative. You must state there is a change of sign, and you must state that the solution lies between these two values to get the mark in the exam. It will often be worth a couple of marks, so make sure you include all the key bits of information. Again, any key facts on here that you don't know, write down, highlight, put them in a bubble, and make sure they stand out. Here we've got an example showing how we're going to look at the equation x cubed plus 2x minus 6 equals 0, and we're going to show it has a solution between the values x is equal to 1 and the line x is equal to 2. So you can see here, this is the graph of x cubed plus 2x minus 6. And we're looking for the solution. Now that solution is the root. Okay, so the key words in here, we've got the word show, the equation that has been given. Look at this equation, it is equal to 0, so you don't have to do anything with the equation first because it's already equal to 0. You're finding the solution. Okay, that's where you cross the x-axis, so it's this point here. And it's saying that the solution is between x is 1 and x is 2. If you look at the graph, x is 1 is here, and x is 2 is here. You can see the root is between 1 and 2. So we've got to show that the root is between these two values given. So our key facts. You are going to substitute the values of a and b into the function f of x equals 0. If there is a change of sign, okay, then you have got a root. So the root of the solution lies between the values x equals a and x equals b, as we've just looked at. So it's really important that you're looking for this change of sign, and in the exam you must write this last sentence. There is a change of sign, therefore the root or solution lies between the value of x is a and x is b, in this case 1 and 2. This symbol here means implies, so you can just use that as shorthand, and this notation here means therefore, again you can just use it as shorthand. So as I said, here is the solution where we're crossing the axis, and we've got to work out why there is a solution between 1 and 2. By drawing the graph, you can see it. You can see the solution is between 1 and 2, but we have to do it mathematically using this method here called the change of sign. Have a go. See if you can do it before I do it, and then press play when you're ready to hear the answer. Fantastic. Hopefully you've managed to have a go at working out when x is 1 and x is 2. So what that means is we're going to substitute the value of 1 into the equation here, x cubed plus 2x minus 6. So f of 1. So 1 cubed plus 2 times 1 minus 6. So 1 cubed is 1 times 1 times 1 is 1. Plus 2. So 1 plus 2 is 3. Take away 6 is negative 3. So f of 1 is negative 3, as you would expect from the diagram. You've got 1 down here, coming down to this point here, down at negative 3. We have got a negative answer, so this is less than 0. We're going to do the same for 2. So if I substitute 2 into the equation, you can see it's above the line here. So f of 2, instead of writing x, I'm going to write 2 cubed plus 2 times by the value of x, which is 2. So 2 times 2 is 4. Take away 6. So 2 cubed is 2 times 2 times 2, which is 8, plus 4, take away 6, which will give me an answer of 6. So f of 2 comes up to this value here of 6. You can see in the graph it's come across. So this 6 is positive. This is greater than 0. So you can see we have got a change of sign. So to get the full marks in the exam, you must state there is a change of sign. So you must write down there is a change of sign. Therefore, the root or solution lies between x is equal to 1 and x is equal to 2. So make sure you write these last two sentences down along with the working out that you've put up here in order to get the full marks for the exam. You could be awarded up to 3 marks for this in the exam, depends on which exam board you're doing and how generous they are on the marks on each question. So make sure you've got this clearly in your head, that you understand what this change of sign is. You're going to have a practice at 2 questions in a minute, so have a look at it carefully and make sure you know how to do this question. Okay, now it's your turn. You're going to have a go at answering these 2 questions. So you've got to show that the equation x cubed plus 4x minus 1 equals 0 has got a solution between 0 and 1. And you're going to show that the equation x cubed minus 3x squared is equal to 3, or negative 3, has a solution between x is equal to 2 and x is equal to 3. I'm just going to say be careful on question 2. Look at the difference between equation for 1 and equation for 2. What is the difference? Okay, make sure you are clear on this. So you're going to do your substitution. You've got your change of sign and your equation that you're going to be writing about. So make sure you've got this included. Have a go, press pause and then press play when you're ready to hear the answer. Fantastic work. So hopefully you've managed to have a think about this and realise this equation up here is equal to 0. So all you've got to do is substitute in the value of 0 and 1. Be careful down here, this equation is not equal to 0, so if you need to make any changes, just pause and then make any changes you need to, because this one isn't equal to 0, that's the difference between them, and see if you can work them out. So we're going to start off by substituting 0 into this equation here. So you've got 0 cubed plus 4 times 0, take away 1. You should have found you got a value for -1. This is negative. Okay, so you've got to state that that is negative. Next, we're going to substitute 1 in. So when I substitute 1 into this equation here, I've got 1 cubed plus 4 times 1 minus 1 is going to give me a value of 4. This value here is positive. So I've got a negative answer and I've got a positive answer. So because there is a change of sign, the root or solution lies between x is 0 and x is 1. So it's really important you write this final sentence to say what you have found. That will give you full marks in the exam. The next question, we've got to show the equation x cubed minus 3x squared is equal to -3. So this is the trick because this is not equal to 0. So we've got to add 3 to both sides to make it equal to 0. So we've got x cubed minus 3x squared plus 3 is equal to 0. You're showing this equation here has got a solution between x is 2 and x is 3. So you should have substituted 2 and 3 into this equation. So if you substitute 2 in, you get 2 cubed minus 3 times 2 squared plus 3, which will give you an answer of -1, which is less than 0. Then we substitute 3 in. I've got 3 cubed minus 3 times 3 squared plus 3. That is going to give me an answer of +3, which is greater than 0. This implies there is a change of sign, therefore the root or solution lies between x equals 2 and x equals 3. Give yourself a big tick if you got those correct, and an extra big tick if you managed to work out this one, because this was not equal to 0 in the first place, so make sure it didn't catch you out. So well done, give yourself a big tick if you got it right. Great work. Now sometimes when you've been given values, you won't get a change of sign. So when you're looking at a graph like this, okay, so this is a quadratic graph, you can see here there is no root because this graph is above the x-axis. So the graph does not cross the x-axis, so there is no root or there is no solution. So that means both of the values that you choose, so say you chose the values for 1 and 2, if you substitute 1 in, you get a positive answer. If you substitute 2 in, you also get a positive answer. Because both of these are positive, or it could be both negative, there is no change of sign, which means there is no root or solution. The graph does not cross the x-axis between the two x values. In the exam, you're unlikely to come across a no change of sign case because they want you to find out what the root is. But this is what it means if there is no change of sign, why it doesn't work. Now, once you have found there is a change of sign in the equation, you will be asked to rearrange the equation, and they will say rearranged. So take the original equation and they'll say rearranged to get a new equation. So your key fact here is basically you've got to make x the subject of the formula, and sometimes it is more obvious than other times as to when you are doing that. And it depends on the exam board as to whether they ask you to do this rearrange stage or not, because some exam boards don't. For example, OCR generally don't ask you to do the rearrange bit, they just rearrange it for you. But on Excel, you will be expected to rearrange the equation. So it depends on which exam board you're sitting as to which one you have to do. So make sure you know your exam board and check with your teachers. So we're going to look at making x the subject of the formula. And I'm going to show you how to do that now. So we're going to show that this equation x cubed plus 2x minus 6 equals 0 can be rearranged to give x is equal to 6 divided by x squared plus 2. You will notice this is the same equation that we started it with to show there was a change of sign. So it's exactly the same equation, and depending on how you rearrange this equation depends on which route you go to. So we've got to rearrange it to give you x equals. Now it's really tricky to decide how to rearrange this equation because you've got an x squared down there. It's going to be involving this x here. But when you look down here, you've only got a 2. So the x that we're going to be rearranging to find, it's got to be combined with both of these, and I'm going to show you how to do it. If you think you know what to do, have a go. Great. But if you don't, just listen. So our keywords in the question are the word show, the equation that's been given, the word rearranged, and what you're trying to make. So our key facts, we're going to make x the subject of the formula. So we're going to be finding a combination of both these two x's together in order to get the x squared plus 2 in the denominator. So to start with, we're going to get rid of the thing away from the x's, which is this negative 6. So the opposite to negative 6 is going to be plus 6. So I'm going to add 6 to both sides. When I add 6 to the left-hand side, the negative 6 disappears because these two become 0, and 0 plus 6 is 6. Now I've got to get an x because I'm going to do a divide in a minute, and I've got to end up with x squared plus 2 in the denominator. Now, to be able to get an x squared plus 2 out of this, you're going to have to factorise. So both these terms have got a common x. So you're going to take x out as a common factor. So we've got x bracket x squared plus 2 in the brackets, because x times x squared gives me x cubed and x times 2 gives me 2x. So if you divided both of these terms by x, that will tell you what is in the bracket here. It's called factorising. Once we've factorised, we now need to get rid of this term here next to the x, because I've got to get x on its own. I've got to get x equals. So we're going to get rid of this term next to the x, which is the x squared plus 2. The opposite to multiply by x squared plus 2 is divide by x squared plus 2. So I'm going to divide both sides by x squared plus 2, which gives me x equals 6 over x squared plus 2, therefore shown. So we have shown what you've been asked to do in the question. This is a very tricky rearrangement because you've got to factorise as well in here. Often it's only worth 1 mark because it tells you what you've got. It tells you what you're rearranging to. So if you find this step here difficult, it doesn't matter because they will tell you what you're rearranging to, because this is what you're going to need to do the next 2 steps to be able to find the solution. Now graphically, we have got the equation here on the right hand side of y is equal to x cubed plus 2x minus 6, which is what we've seen before. And this is the solution here where we cross the x-axis. But over here on the left, on this graph, I've got the graph of y equals 6 over x squared plus 2, which is the right side of this equation here. And on the left-hand side, I've got the graph of y equals x. Now, these two graphs I've just drawn separately. Now, you will notice that the point where these two graphs cross, okay, is the same as where this original graph crosses here between 1 and 2. So alpha is the solution or the root. So when you've got the equation rearranged, the y equals x and the y equals 6 plus x squared divided by x squared plus 2, where those two graphs meet gives me the solution. When it's rearranged to be equal to 0, where that graph equals 0, that is the solution there. So you can see I get the same solution out between 1 and 2, but it's drawn in a different way. Now when you go on to iteration at A level, this graph, we look at something called staircase diagrams and cobweb diagrams, and we look at the pattern that happens with these iterations that we're going to look at later on. At the minute, we're not going to be doing that for GCSE. We're just going to show you how to get to this root here, alpha, from this rearranged equation. That's what you need to know for GCSE. Now it's your turn. You're going to have a go at working out the rearranged equation. So remember, rearranging means make x the subject of the formula. So that's what this word here, rearranged, means. So you've got to rearrange this equation, x cubed plus 4x minus 1 equals 0, into the x equals a quarter minus x cubed over 4. And the second one, x cubed minus 3x squared plus 3 equals 0, rearranging to give you the cube root of 3x squared minus 3. Press pause, have a go at working out the answer, and then press play when you're ready to hear the answer. Okay, great work. I'm going to give you a little hint if you're still struggling. So on this first question here, we've got to find this x here. You can see it is divided by 4. So the x that you're looking at finding is this one here with the 4x in, because when you divide by 4 later on to get rid of this times by 4, that's where you get in the divide by 4. So the x you're trying to find is this x here on this question. So to start with, you should have looked at this take away 1. The opposite to take away 1 is plus 1. So you're going to add 1 to both sides, giving you x cubed plus 4x is equal to 1. We now want to get this x here, so we've got to get rid of this plus x cubed here. So the opposite to plus x cubed is subtract x cubed from both sides, leaving me with 4x is equal to 1 minus x cubed. We now need to get the x on its own, so we're going to get rid of this multiplied by 4, so we're going to divide both sides by 4. Dividing by 4 leaves me with 1 minus x cubed over 4. Now, if they didn't say how to rearrange it, then this answer is perfectly fine. But the question said rearrange it to be x is equal to 1 over 4 minus x cubed over 4. So this is a one fraction, but on the answer I've got two fractions. So we can just separate this into two separate fractions. So I can divide the 1 by the 4 and I can divide the minus x cubed by the 4 to write it out separately to show that you've got this answer here. So just separating out your fractions, these two things are exactly the same. Give yourself a tick if you managed to show. Well done. Now this question here, we've got to rearrange to get the x is equal to the cube root of 3x squared minus 3. So you should have spotted this x here is the one you're trying to rearrange because the opposite of cubing is cube root. So we're trying to find this x here. So to start with, we're going to get rid of the plus 3. So we're going to subtract 3 from both sides. So I've got x cubed minus 3x squared is equal to negative 3. The opposite to take away 3x squared is going to be plus 3x squared. So I'm going to add 3x squared to both sides. So I've got x cubed is equal to 3x squared minus 3. Then I've got to get rid of this cube root. So the opposite to cubing is the cube root. So I'm going to take the cube root of both sides, leaving me with x is equal to the cube root of 3x squared minus 3, therefore shown. Give yourself a big tick if you got that one correct. Well done, great work. We're now going to show you how to turn this equation that you've just rearranged into an iterative sequence or iterative formula. Now the key facts to turn the equation we've just seen into an iterative formula are that we take the x which is on the left hand side and we're going to replace it with an xn plus 1. Now this will give you the next value for x. So this is the notation we use in our iterative formula. So any x on the left hand side is replaced with xn plus 1 and this will give you the next value for x. On the right hand side we're going to replace all the x's, and could be more than one x, with xn. So there could be one x or there could be two x's. You can replace all those with xn. And this is the current value for x or the initial value for x, depending on what information is given to you. So you'll start off with the initial value and then you can work out more values, and that's the iterative process. So we will move on to that shortly. But we're going to first of all have a go at working out some iterative formulas. So remember, we're going to look at writing an iterative formula. The word write, the equation that is given, and the iterative formula are the key words in the question. Our key facts are what we've just looked at. We're replacing the x on the left with xn plus 1 and the x's on the right with xn. So all we've got to do is replace this x with xn plus 1 and the x on the right with xn. Press pause, have a go at work writing it down, and then press play when you're ready to hear the answer. Fantastic, if you wrote xn plus 1 is equal to 6 over xn squared plus 2. You're going to have a little practice of writing some iterative formulas, then we're going to take this iterative formula and you're going to have a go at working out how to do it. Now here we've got two questions. You are going to write the equation x equals 1/4 minus x cubed over 4 as an iterative formula, and x equals the cube root of 3x squared minus 3 as an iterative formula as well. Remember, these are the two equations that we saw in the last two examples. You're now just writing them as iterative formulas. Remember, these are the steps how to do it over here. Press pause and then press play when you're ready to hear the answer. So, fantastic. Hopefully you've all written xn plus 1 is equal to 1/4 minus xn cubed over 4. And for the second one, you've written xn plus 1 is equal to the cube root of 3xn squared minus 3. So all the x's on the left have been replaced with xn plus 1 and the x's on the right have been replaced with xn. This is creating an iterative formula, and we're going to learn how to use this iterative formula to create a sequence to be able to work out the root or the solution to the equation. So we're nearly at the end of the sequence that we've got to do. So our last step is coming up. So our notation that we're going to be using with the iterative formula starts off using the notation x0. So this is equal to your initial or starting value, and this will be given in the question. Sometimes you will be given the value of x1 to start with, but generally is the value of x0. Okay, so we start with x0. Now, if you substitute x0 into the right-hand side of the equation, that will give you the first value, x1. So x1 is my first value, and that is found by substituting the value that is given in the question into the right-hand side of the equation. To find the second value, x2, we're going to substitute in x1, so the value you've just worked out over here, into the right-hand side of the equation. So you're going to take the same equation and you're going to substitute the values in. Then to find x3, which is the third value, you're going to substitute in x2 into the right-hand side of the equation, and this keeps going for as many values that you're expected to find. Often in the exam it's just finding the first two values. It may be the first three values or even four values. If it says find the answer alpha or find the root, then you'll need to find the first four values and write down those solutions. And it's really important that you do not round your answers at this stage here. So you write down all your answers as you're working out x1, x2, x3, and then round them all at the end. Otherwise you'll get an error when it comes to the exam because your answer isn't accurate enough. So make sure you do not round until your final answers. Now we can do iteration on the calculator, and it's really quick and easy to do iteration on the calculator. You'll be given an expression f of xn plus 1 is equal to f of x, like we've just seen, and you'll be given a starting value such as x0 is equal to a. So a is my starting value, or x0 is the starting value. And on your calculator, you'll press the value given for a, for example 5, so you'll press 5 and then press the equals button. Then you'll type in the equation that has been given on the right-hand side, okay, and replace any xn's using the answer button on your calculator. So you'll press the answer button instead of typing in the value xn. Then if you press equals, this will work out x1, so this will find the first value. If you press equals again, then that will give you x2, and if you keep pressing equals, it will find subsequent solutions, x2, x3, x4, etc. Now the solution is the root when alpha and the digits do not change. So if you keep pressing equals here, the solution will not change, and when it gets down to the point where the solution doesn't change, you have hit your root alpha. So this is how we're going to do it using your calculator. I'm going to show you both steps alongside each other on the example we've been using, and then you're going to have a go. So our keywords in the question are the iterative formula xn plus 1 is equal to 6 over xn squared plus 2. This is what we showed we had to rearrange to and then had to write it as an iterative formula. You're told the starting value x0 is equal to 1.45, and you've got to work out the values of x1, x2 and x3. Okay, remember our key facts. We're going to press a is equal to 0, where a is this value here of 1.45. You're going to replace the equation with, instead of writing xn, you're going to write answer. So where xn is in this equation here, you're going to write the answer button. You're going to press equals to find x1, keep pressing equals to find the value of x2 and x3. Solution is the root where alpha is, and this is where the digits don't change anymore. This is my starting value. So we're first of all going to work out x1. So x1 is when n is equal to 0. So if n is equal to 0 in this equation, 0 plus 1 gives me 1. x0 is here on the right, so I've got x0 squared plus 2. So x1 is equal to 6 divided by x0 squared plus 2. So n is equal to 0 because that's what we're using for my starting value. Now instead of writing this value of x0, I can use what it's been given in the question, 1.45. So 6 divided by 1.45 squared plus 2. If you type that in on your calculator, you'll get the value for x1. But there is a quicker way of doing it, not necessarily for this first step here, but when you come to find the subsequent ones, you just keep pressing equals, it is so much quicker. So on your calculator, you've got 1.45 equals. Then you're going to use your fraction button, and then you're going to press 6, and then you're going to go over the answer button squared plus 2 equals. And when you press equals, you should get the value for x1 equals 1.462522852. Now you need to write this answer out in full because you need to use all these digits to calculate x2. So it's really important you use all these digits. If you type it in the calculator like this, you just press equals and the calculator does it for you automatically. If you rounded to 1.46 or even 1.5, you would get the next solution wrong. So you must use all the digits here, which is why it's really easy to do it this way on the calculator. Now to find x2, we're going to use our x1 value. So we know the answer for x1 is 1.462522852. Now n is equal to 1. So we're going to substitute 1 in on the right hand side. So I've got x1 squared plus 2 in the denominator. So we're going to do 6 divided by that answer. But here n is equal to 1. So 1 plus 1 is 2. So the right hand side now becomes x2, or the left hand side. So this left hand side is x2 because 1 plus 1 is 2. So I've got x2 is equal to 6 divided by x1 squared plus 2. But we know x1 squared, or x1 is 1.46, etc. So we can write the whole of that value in. On your calculator, all you have to do is press the equals button again, and that will give you the answer of x2, which is 1.449634937. So it's really important you write this whole value down because you'll need to use this to work out the value of x3. So if you write this out in full, you can use all digits to calculate the value of x3. Have a go at working out x3 before you see the next slide. See if you can work out what the value will be. We've now got our value of x2. Once we've got this value of x2, we're going to substitute this into the equation. So n is now equal to 2. So the x2 down here, n is equal to 2. On the left hand side, I've got 2 plus 1, which gives me 3. That gives me the next term. So x3 is 6 divided by x2 squared plus 2. I've replaced the x2 with this value of 1.46, etc., all squared plus 2. Again, on your calculator, all you've got to do is press equals, and it will give you this value here for x3, 1.462900317. You need to write it out in full, and then you can round your final answers once you've written them out in full. So it's really important you write them out in full in the exam. Even though you think it's taken a lot of time, you will get marks for showing your full values. So I've just rounded the values to 4 decimal places. It may say in the exam how to round it to. It may say 3 decimal places, 3 significant figures. If you're unsure, I go more accurate on this question. So I've gone 4 decimal places here because then it is you're safer. So they generally give you more marks if you're more accurate. So you've got 1.4625 for the x1. x2 was 1.4496, so just rounded this number here I've got to 4 decimal places, and x3 is the value I've got here to 4 decimal places, 1.4629. Now if you keep pressing equals on the calculator, that will give you the root of a solution. Now for this particular example, it's not a very good example in finding this because your sequence actually oscillates, so you can't actually find the root accurately on here. If you have got a scientific calculator which will solve an equation for you, you can actually solve this equation because it's got an x cubed in it on your calculator to work out the actual value. But for the exam question here, all you've got to do is find x1, x2 and x3. So these are the 3 values, so that's all we need to do on this question. Make sure you've made a note of how to do this on your calculator so you understand the steps to find the values of x1, x2, x3, etc. and how to use your calculator to help you. You're going to have a go at doing 2 examples, so make sure you've pressed pause, written down any key facts you need, and then press play when you're ready to hear the answer. Now it's your turn to have a go at doing the two examples that you can see here with xn plus 1 is equal to a quarter minus xn cubed over 4. Again, this is the same equation that you made initially when you rearranged it, turned it into an iterative equation. The starting value here is x naught equals to 0, and you've got to find the values of x1 and x2. Similarly here, the second example is linked to the second examples we've had all the way through. Xn plus 1 is equal to the cube root of 3xn squared minus 3 with x naught equaling 2. We're going to find the values of x1, x2, and we're going to round the answers to 3 decimal places on the second one. And for a bonus point, if you can find the value of alpha, which is the root, then you can get a bonus mark here as well. So you've got 2 marks for finding each solution here, and then a bonus for finding alpha. Press pause, have a go at working out the answers, and then press play when you're ready to hear the answers. Excellent. So hopefully on the first one you typed in 0 equals on your calculator, then you did 1/4 using the fraction button, minus fraction button again, answer cubed divided by 4, and press equals. You should have got the value of 0.25. So this is our starting value. Give us a value of 0.25, or it probably came up with 1/4. If you press equals again on your calculator, you'll get another fraction, and if you press convert it to a decimal, x2 is equal to 0.2460935. If you keep pressing equals, okay, you should come down to a root alpha being 0.2462661722. So there's your value for alpha. Give yourself a tick for each one you got correct. Well done. The second example, you've got x naught being 2. So on your calculator, you're going to press 2 equals. Then you've got to do the cube root button, 3 times the answer button squared minus 3, press equals, and that will give you x1, which is 2.080083823. Press equals again, it will give you the value for x2. The question here says round to 3 decimal places, so I've just rounded this answer here to 1, 2, 3 decimal places, which gives me 2.080. Once you press the equals again, that gave you x2, which was 2.153015141. Rounded this to 3 decimal places, 1, 2, 3, look at the 0, rounds down, so you've got 2.153. And if you keep pressing equals, and you'll need to press equals a lot more on this one than you did on the top one, that will give you the answer for alpha, which is 2.5320888886. Rounding again to 3 decimal places, we have got 2.532 because we've got a 0 here for the 4th digit, but again keeps it the same. So this is my value for alpha. These are all the steps that you need to be able to do iteration. So remember, you need to be able to do the change of sign, you need to be able to rearrange, write it as an iterative sequence, and then you need to be able to use the calculator to work out the roots or the values to the solution, working out x1, x2 and alpha. So they're all the steps we've been looking at. Thank you for listening. Make sure you've written down the key steps carefully and practice lots of these questions to get really good at them. They will come up in your exam. Iteration is a topic that will come up on a calculator paper, and it will come up. So make sure you know how to do it.